Hi, today we will talk about
Alcohol metabolism.
what happens to the alcohol that we consumed after a party, and how our body metabolizes this compound. And also, what are the drugs that can inhibit the effect of alcohol within our body? Come with me, let's find out.
In the year 2019, 33.3% of respondents aged 60 to 69 were alcoholic drinkers. In same exact year, 49.9% of men and 14.8% of women were considered alcoholic in the Philippines. Have you guys met Peter? Well, Peter is celebrating his birthday today with his friends. They set up a bonfire and a bucket of tequila and ice-chilled beers. Ingested alcohol by Peter is absorbed in the stomach at about 20% and about 80% in the small intestine, which the small portion of this alcohol directly goes to the hepatic portal vein towards the liver, where it is being metabolized. Ethanol metabolism primary site is the liver. However, several organs can also metabolize ethanol.
Now, let's move on to the process of alcohol metabolism.
First, ethanol present in Peter's body will be converted directly into acetaldehyde. Acetaldehyde is more toxic than ethanol in cellular level. Ethanol is converted by an enzyme called alcohol dehydrogenase, which with the help of nicotinamide adenine dinucleotide as a cofactor, which will in turn becomes NADH+. Small percentage of ethanol can be oxidized into acetaldehyde into two other ways, by catalase and by cytochrome P450 dependent monooxygenase. Ethanol can induce monooxygenase consumption where bulk reactive oxygen species is formed, which can cause liver damage. Acetaldehyde is responsible for hangover effect that causes headache to those who take it. Further conversion happens to acetaldehyde, as the enzyme acetaldehyde dehydrogenase catalyzes acetaldehyde conversion into acetate, which needs nicotinamide adenine dinucleotide as its cofactor. A fun fact: regular consumption of alcohol can result to formation of beer belly. So how? During metabolism of alcohol, the cell is in a special metabolic state that increases the fatty acid synthesis, resulting to formation of beer belly. Peter will experience a tremendous result of drowning himself with alcohol by the next day. He will feel headache due to hangover that is caused by buildup of acetaldehyde in the body. In this case, Peter can bypass hangover effect by taking fumipizole. It's a competitive inhibitor of an enzyme alcohol dehydrogenase to prevent the formation of acetaldehyde and to prevent the sickness induced by alcohol. On the other hand, a drug that can inhibit the conversion of acetaldehyde to acetate is called disulfiram. This drug can be used to treat patients with severe alcoholism. This drug will limit the conversion of acetaldehyde to acetate. That can cause increased level of acetaldehyde in the body, causing headache and hangover, which in turn can make the patient withdraw from alcohol consumption on regular basis. But thanks to the fact that Peter is a moderate drinker of alcohol. A reminder from Peter: drink moderately. Thank you for listening. I am John Paul C. Ardenia, a Bachelor of Science in Pharmacy student.
Antioxidants and free radicals. I guess you have mostly heard these terms in beauty and health TV commercials and advertisements in all platforms. But do you know what antioxidants are? And why is it necessary to eliminate free radicals? Yes, you are here for a reason. Today, let's dive into the world of pharmaceutical chemistry as we explore antioxidants, free radicals, and oxidation reduction reaction.
Have you ever wondered what antioxidants are? So let us start this discussion with these questions. What are antioxidants? Antioxidants are reducing agents responsible for inhibiting the oxidation of other molecules, hence, they are used to reduce another reactant while being oxidized itself. Therefore, antioxidants undergo oxidation in order to reduce other molecules. In other words, antioxidants loses or donates electrons, which implies the oxidation process. Antioxidants prevent oxidation in other molecules, but they themselves undergo oxidation. Antioxidants come up frequently in discussions about good health and preventing diseases. These powerful substances, which mostly come from fresh fruits and vegetables we eat, prohibit the oxidation of other molecules in the body, which explains why it is important that we consume antioxidants in our daily living. Since we have mentioned oxidation in our previous slide, let us identify what is oxidation and why is it affiliated with antioxidants and free radicals. So oxidation is a chemical reaction that can produce free radicals, leading to a chain reaction that may damage cells. So basically, free radicals are formed through the process of oxidation. Later on, we will identify why does these free radicals cause damage to our cells.
Now that we have come to understand that antioxidants are reducing agents that prevents oxidation by which free radicals are formed. So, what are free radicals? And why is it necessary to be eliminated from our body?
Next up are free radicals. Naturally, the human body produces these molecules. Free radicals are any molecular species capable of independent existence that contains an unpaired electron in an atomic orbital, which renders it unstable, highly reactive, and can damage cells, causing illness and aging. The instability of the free radical is one main reason why it damages healthy cells. They are known as scavengers because they forcefully take electrons from healthy cells, which in return damages it. As you can see in the picture, on the left side is a free radical, while on the right side is a healthy cell. It is visible that the free radical is missing one electron, which renders it an unpaired electron. So it is taking one electron from a healthy cell, which in return causes a damage to this healthy cell. Let's discuss the free radicals generating substances, which are substances that we should be avoiding. First would be fried foods, alcohol, tobacco, air pollution, and pesticide. As you can see, the consumption or exposure to any of these substances generates free radicals in our body. Now that we have identified the culprits behind generating free radicals, let us enumerate the effects of free radicals in the human body. First off, accelerated aging, damaged or mutated cells, broken down tissue, activation of harmful genes within DNA, an overloaded immune system, and heart disease.
As what you have seen, free radicals are obtained from our environment, lifestyle, and diet. They are much more harmful than we have ever imagined. Free radicals are naturally produced by our body, and antioxidants are there to combat them. But when levels of antioxidants in the body are lower than of free radicals, oxidation causes disruption to the human body and gradually destroys it. That is why it is also necessary that we consume antioxidants from our diet. To give you a lucid explanation, I will show you the iodine antioxidant reaction, which will also show the mechanism of oxidation reduction reaction.
Let me show you the iodine antioxidant reaction. In this experiment, we have utilized 3 antioxidants, the vitamin C or the ascorbic acid, glutathione, and vitamin E or known as the alpha tocopherol. In this brown solution that are within these Erlenmeyer flasks is the combination of iodine solution and water. So as we put vitamin C to iodine and water solution, the color of the solution changes from a brown to a clear and transparent one. With glutathione, it also has the same result. It was able to clarify the brown solution into a clear and transparent one. And lastly, with vitamin E, it renders the same result as the previous antioxidants. So how did this happen? Let us find out. For the rationale, the antioxidant substances in the sample, such as vitamin C, glutathione, and vitamin E, are reducing agents that were capable of reducing elemental iodine to iodide ions. Let us take a closer look to vitamin C in iodine solution. The brownish color of the iodine solution will become colorless as it reacts with vitamin C under oxidation reduction reaction, whereby vitamin C reduces iodine to iodide ions, and in the process it is oxidized to dihydroascorbic acid. The vitamin C had underwent oxidation, which has converted it to dihydroascorbic acid in order to reduce elemental iodine into iodide ions. So one molecule of iodine is converted into 2 iodide ions. When all of the iodine has been reduced to iodide, the solution loses its color, which signifies that the addition of the antioxidant, which is your vitamin C, has neutralized the iodine ions, reducing it to iodide ions. And for the remaining 2 antioxidants, we first have glutathione. Glutathione is known as a powerful antioxidant. In addition to its remarkable antioxidant properties, the discovery of its anti-melanogenic properties has led to its promotion as a skin lightening agent. Glutathione acts as tyrosinase inhibitor. Tyrosine is an enzyme that catalyzes the biosynthesis of melanin, which is the natural skin pigment. Basically, tyrosine is an important component in the biosynthesis of melanin. Without tyrosine, melanin will not resurface. So glutathione has the ability to inhibit the production of tyrosine, which follows that if there is no tyrosine, there will be no melanin. And if there is no melanin, there is no natural skin color, hence a fair and lighter color of the skin. For vitamin E, or known as the alpha tocopherol, it is a fat-soluble antioxidant that is essential for the maintenance of a healthy skin. It can absorb the energy from the UV light, by which it plays an important role in the photoprotection, preventing UV-induced free radical damage to the skin. The explanation behind the interaction of iodine and antioxidant is the oxidation-reduction reaction. The oxidation reduction, or known as the redox reaction, is a type of chemical reaction that involves a transfer of electrons between two species, which means that there is one molecule that gains electrons and there is one molecule that loses electrons. Oxidation reduction reaction is any chemical reaction in which the oxidation number of a molecule, atom, or ion changes by gaining or losing an electron. In other words, the oxidation number of a molecule or an atom depends on its ability to either gain or lose an electron. In this picture, it is depicted that under the oxidation process, it has lost an electron, while under the reduction process, it has gained an electron. Always remember this abbreviation, LIORA, which means loses electrons, therefore it undergoes oxidation, so it is a reducing agent. As you can see, the hydrogen has lost an electron. It is undergoing oxidation, therefore hydrogen is identified as a reducing agent. While on the right side, GROA, which means it gains electrons, it undergoes reduction, therefore it is an oxidizing agent. Always remember that in the process of oxidation, there is the loss of electron. In the process of reduction, there is the gain of electron. In the previous experiment, we can identify that in the right side, which is the oxygen undergoing reduction, is our free radicals. Remember that it has gained electrons and was reduced by the antioxidant. Therefore, it undergoes reduction and basically, your free radical is an oxidizing agent. While on the left side, it is the antioxidant because it undergoes oxidation. It donates or loses electrons in order to stabilize the free radicals, by which the process it has underwent was oxidation, which means that it is a reducing agent. Always remember these two abbreviations when it comes to the oxidation-reduction reaction. So redox reaction are comprised of two parts, a reduced half and an oxidized half. The reduced half gains electrons and the oxidation number decreases, while the oxidized half loses electrons and the oxidation number increases. Always remember that in oxidation, there will always be loss of electrons. So if an atom loses electrons, oxidation favors it. That is why in the oxidized half, losing of electron increases the oxidation number. For you to thoroughly understand, here is a closer look. Always remember the LIORA and GROA. For the reduced half, it gains electron from a reducing agent because reducing agents are the ones that donates electron. Reduction, which means gain. As you can see in the picture, the one that gains the electron is a free radical. It gains its electrons from a reducing agent because as you can see, the antioxidant is offering the electron, which means it is the antioxidant that donates the electrons. Therefore, the free radicals are gaining electrons from the donation of the antioxidant. Remember, free radicals are the ones that receives or gains electrons from antioxidants because it is unstable and it has an unpaired electron. While the oxidized half, it loses electron to an oxidizing agent because oxidizing agents are the ones that accepts electrons. Oxidation, which means loss. Always remember, antioxidants are the ones that donate electron to free radicals. As you can see in the picture, the antioxidants again is offering or donating the electrons to the free radicals. Therefore, it has lost electrons towards an oxidizing agent, which is your free radical. Just remember, if the reduced half gained electrons, where did it come from? Where did it gain it? So, it gained it from the reducing agent. It has gained it from the reducing agent because again, the reducing agent donates it. So what will the free radical do? It will receive the donated electrons. While in the oxidized half, it loses electrons. So where will the electrons go? Who are the ones that receives these lost electrons? Therefore, it is the oxidizing agent because the oxidizing agent are the ones that accepts electron. So if an atom loses an electron, which is the ability of an antioxidant which undergoes oxidation, where will it go? It will go to an oxidizing agent, which is your free radicals. So always remember that antioxidants are reducing agents that donate electron to free radicals, which are oxidizing agents, which in return accepts these electrons and becomes stable. In summary, reduction happens when free radicals, which are oxidizing agent, gains electrons from the donation of the antioxidant, which are reducing agent. Oxidation happens when antioxidants or reducing agents loses or donates electrons to the free radicals, which are oxidizing agent. Keep in mind, when we say reduction, we are always gaining. When we are undergoing oxidation, we are always losing. Gaining of electrons and losing of electrons. I will be introducing to you a tragic phenomenon between an antioxidant and a free radical, entitled the sacrificial bond. In the picture, the reducing agent is the antioxidant, which is the girl, while the oxidizing agent is a free radical, which is the boy. The antioxidant said to the free radical, "I am willing to lose these gifts and give it to you, just so you wouldn't have to go through a painful oxidation. I will do it for you." The free radical or the boy replied, "I am sorry if I am this unstable, but in order for me to keep myself from hurting others, I will accept those gifts and I will gain my stability and be reduced." After the transfer of electrons or the transferring of gifts, this is what the antioxidant thinks. "I lost everything just because I have learned to give everything to the one I adore." What the free radical or the boy thinks, "I am grateful to have the chance to gain everything that was given to me by whom have adored me. I will no longer cause harm." As you can see, this epic tragedy where the girl, which is the antioxidant, gave her electrons to the boy, which is the free radical, to prevent the boy from experiencing what she had called painful oxidation. She sacrificed herself to undergo oxidation rather than letting the boy be the one to experience it. Whereas the boy who is unstable had become stable because he has accepted the electrons given by the girl, by which being stable means he will no longer do harm and be happy. I hope this short story will help you understand the bond between antioxidant and free radicals. And this would be the end of the discussion. I am Jordan L. Guardamano, a BS Pharmacy student. Thank you for listening.